Okay, continuing on. In 2013, Builder Reinhardt Structural Group was retained to provide structural engineering services. We requested a general summary level opinion report of the overall construction quality of the building and select components, systems, materials, and methods of construction. Determination of the approximate life expectancies of the structural elements and building envelope were requested. Their proposal stated, the field condition survey and report requirements were not to be construed as being a detailed investigation or design review, and no intrusion or destructive testing is to be involved. The board understands that not all aspects of the construction may be visible, as they may be concealed by other building components and/or finishes. The fire alarm excluded also were the fire alarm and security systems, site civil systems and drainage, and also the mechanical, electrical, and plumbing systems. Their report dated May 15, 2013. A structural assessment was performed at the clubhouse on April 16, 2013. The assessment consisted of a visual survey of the exterior elevations, interior spaces, and roof structure and roof area. The visual survey was of the structure's current state and did not involve destructive activity to view inaccessible areas. The survey of the exterior included that we had stair-step, horizontal, and vertical cracking in concrete masonry walls, which was observed in numerous locations. There was sealant missing at several locations and penetrations. We had paint peeling, and there was some delamination of the stucco finish. The survey of the building interior indicated that we had slab cracking in terrazzo floor, widths of 1/16 of an inch, plus or minus. The survey of the roof exterior and the interior attic space stated the current roof system is a newly recoated in September of 2012, sprayed polyurethane foam system, which consists of an initial silicone base coat, a layer of sprayed polyurethane foam, followed by a layer of silicone top coat, and finished with sprayed on roof granules. At the time of the site visit, the roof reported to be performing properly for a majority of the system. And it's kind of interesting because that's one area that the hurricane did get to us, and we do have a claim and settlement from the insurance company to replace the roof. The structure appears to consist mainly of pre-engineered metal plate connected roof trusses with plywood sheathing. Truss to wall tie-down straps connections were discernible at some locations along the perimeter. Gable truss to wall connections were also visible at some in-wall locations. The roof exterior surfaces and portions of the attic crawl space were visually observed. Observations made are as follows. Interior attic space. A white residue was observed on several truss members throughout the roof structure. Some wood staining in the roof sheathing was observed. The staining is consistent with water intrusion. Typical gable in-truss to wall tie-down connection. Typical steel header beam connection. Typical truss to hold down throughout the structure. Possible rodent and or insect activity was observed along the gable section above the kitchen facilities. Roof exterior. The new roofing material seems to have been sprayed over existing connection details in some roof-mounted equipment. Exterior and interior repair recommendations. Builder Reinhardt believes that the observed deterioration to the structure is due to long-term exposure to its environment, which includes ultraviolet rays, moisture, humidity, temperature changes, proximity to a large body of water, etc., and the age of the structure. General restoration and waterproofing project scope. Based on observation made during the condition survey, Builder Reinhardt recommends the following restoration maintenance projects to be undertaken. The items below describe a general recommended scope for a restoration and waterproofing project. The scope also provides for long-term protection and additional potential conditions that are not readily detectable at this time. Concrete repair. Repair wall and floor cracks greater than a 1/16 inch via epoxy injection. Repair concrete crack and spalling on window sills and lintels. Remove and replace joint sealant, including but not limited to perimeter window seals, metal-to-metal joints, and metal-to-glass interfaces, as well as wall penetration joints. Repair interior finishes damaged by moisture intrusion and those affected by repairs. Recoat existing painted wall surfaces after proper surface and substrate preparation. Note that this project scope may require modification based on observations made during project construction, and should conceal detrimental conditions become apparent. Due to the age of the original window system, the application of sealant between the window frame and the joining wall surfaces and between the window glazing and the frame may not mitigate potential moisture intrusion. A replacement plan for the original window system is recommended to be implemented. For future roof system repair or replacement work, the following building code requirements should be taken into consideration. Not more than 25% of the total roof area or roof section of any existing building or structure shall be repaired, replaced, or recovered in any 12-month period unless the entire roofing system or roof section conforms to the requirements of this code. Rooftop equipment, assumed to be air conditioning equipment, was observed while surveying the roof system. The equipment was observed to be fastened directly to the rooftop system. To meet current code requirements, if necessary, all rooftop equipment must be elevated above the roof surface level to at least 8 inches if on a curb, and the height varies if the unit is placed on a platform structure. And the building code identifies the platform height requirements. Optional wind mitigation project scope. Storm hardening and potential wind damage mitigation procedures can be implemented if deemed necessary and/or desirable to increase the wind load capacity of the clubhouse roof structure. Some possible techniques for storm hardening of the roof structure include additional horizontal bracing, gable-end bracing, application of adhesive foam between roof sheathing and trusses, additional connection plates at truss web connections, and additional hurricane tie-down clips from the trusses to the load-bearing walls. Gable-end bracing is intended to increase the resistance of existing gable-end wall construction for wind loads resulting from high wind events. These are only a few general examples of the storm hardening techniques available to the type of construction present at the clubhouse structure. Consideration of Florida building code requirements. When conducting an alteration to an existing building, the 2010 Florida Building Code sets threshold limits for defining a specific amount of work conducted and parallel requirements necessary for that specific amount of work conducted. The threshold limits are established into 3 categories: level 1 and 2 and 3 alternatives. Level 1. Level 1 alterations include the removal and replacement or the covering of existing materials, elements, equipment, or fixtures that serve the same purpose. Level 2. Level 2 alterations include the reconfiguration of space, the addition or elimination of any door or window, the reconfiguration or extension of any system, or the installation of any additional equipment. Level 3. Level 3 alterations apply where the work area exceeds 50% of the aggregate area of the building and made within any 12-month period. Exception: work areas in which the alteration work is exclusively plumbing, mechanical, or electrical shall not be included in the computation of total area of all work areas. Substantial structural alteration. When more than 30% of the total floor and roof areas of the building or structure have been or are proposed to be involved in structural alteration within a 12-month period, the evaluation and analysis shall demonstrate that the altered building or structure complies with the Florida Building Code for wind loading. Closing. If the scope of work required to the existing building is deemed to be a level 3 alteration, and within that scope of work there exists a substantial structural alteration, the structure must comply with the current wind loading requirements. In addition to this structural requirement, there are also fire protection, means of egress, accessibility, and energy conservation. An alteration of this nature and the subsequent requirements would not likely be economically viable to implement with the current structure. Builder Reinhardt believes that provided standard care and diligent regular restoration and waterproofing projects are completed in order to remediate any deterioration of the building envelope and structure in conjunction with ongoing maintenance initiatives, the likelihood of having to bring the structure up to current code requirements is diminutive. Based on the requirements of the current building code, the known conditions of the structure, and the building envelope, and the materials and methods of construction used, Builder Reinhardt believes that the clubhouse structure can be maintained and serviceable for the foreseeable future. This report was done in 2013, 6 years ago. A table is included that identifies clubhouse maintenance projects that could be incorporated into the reserve fund study to anticipate that adequate funding is available for continued use of the structure for the foreseeable future. The table does not include costs associated with minor ongoing maintenance initiatives or any upgrading projects such as window replacement, storm hardening, etc. The table included one project was for waterproofing and limited restoration, which stated the remaining useful life was 0 to 2 years. The life expectancy was 7 to 10 years, and the current estimated cost was $50,000 to $70,000. The second project identified in the table was roof system replacement. The remaining useful life, 10 years. Life expectancy, 15 to 20 years. And current estimated cost was $200,000. They added a note, says actual costs may vary based on scope of work and would be dependent on bids from qualified contractors. Community may consider adding 5 to 19% contingency to account for possible concealed conditions revealed during projects. Ending note on their report. Neither the limited survey nor this report is intended to cover hidden conditions and defects, mechanical, electrical, or architectural features, nor environmental concerns. Builder Reinhardt Structural Group reserves the right to update the information contained in this letter if deemed necessary due to modified site conditions or the availability of any new or additional information. Okay, after reviewing the studies prepared by professional consultants on the clubhouse and recommendations from the Clubhouse Repair Committee, April 12, 2010, the Board of Directors felt it prudent to look at options for financing a project. It appeared that the option of replacing the clubhouse should be considered as the cost estimates prepared by Wanamaker and Jensen, renovation of the clubhouse without modifying the existing structure, the 2052 or updated, or what, let me start over. Renovation of the clubhouse without modifying the existing structure, or renovation of the clubhouse with modification of the structure. Their estimated costs were $2,052,644 to $2,405,413, or the estimate for replacement of the clubhouse was $2,713,693, or a variance of either roughly $650,000 to $300,000, the difference from renovation to replacement. And the board felt that the estimates were reasonably close, and we would have a new energy efficient structure which could last 50 years versus the existing renovated building which could require additional work in another 10 years. In 2013, a plan was developed whereby FVRA would accumulate approximately 50% of the necessary funding through reserves, and the remainder of the funds would come from a construction loan. A timetable of completing the project was set, or in 2021 was adopted as part of that plan. This plan has been followed each year since then in preparation of the budget, which has been voted on and approved each year by our shareholders. Earlier this year, a shareholder requested use of the clubhouse for a gathering, which the Board of Directors approved. Prior to the meeting, as well as at their meeting on January 20th, 2019, a petition was distributed. The petition requested that the Board of Directors call for a special meeting to be held on February 28th to discuss and justify the need for doing general maintenance to the existing building versus a replacement or new building. This meeting also asked for a secret ballot of the shareholder owners to be returned by March 31 of 2019 in a sealed envelope returned to their independent accounting firm that would determine the issue. The names of the originators of the petition were not included on the petition prior to that meeting. Board of Director members met with the organizers of the petition on January 28, 2019 at their request. They presented a petition which was signed by several shareholders and requested a special meeting to discuss the clubhouse project. It was also discussed and agreed upon that a structural engineering firm would be retained to perform a detailed structural analysis and recommendation for the clubhouse. After verifying that the petition met the requirements for calling a special meeting and the procedures documented in our bylaws and the Florida statutes, arrangements were set in motion, and thus the purpose of tonight's meeting. We talked to several structural engineering firms and retained Master Consulting Engineers, Inc. from Tampa, Florida, to do the structural analysis. After visiting the clubhouse on 3 occasions, I think it was 3, they prepared the following report. Jim Meltretter, professional engineer sitting from Master Consulting Engineers, is here tonight to answer any questions you might have. Now I'll go through Jim's report. Jim's report dated March 25th, because I'm only going to hit the highlights. March 25th, 2019. Introduction. As authorized by you, Master Consulting Engineers, Inc., MCE, has inspected the clubhouse at Fairway Village located in Largo, Florida to conduct a condition survey. The purpose of this survey was to assess the condition of the building and conduct an analysis of the conditions. The clubhouse building was constructed in phases. The original building was constructed in 1970. The building has had 3 additions, one in 1973, one in 1981, and one in 1996. And we'll skip down. MCE conducted a condition survey on February 28th and March 8th. A summary of the site visits is presented below. And I'll hit the survey of the exterior. I'll hit just a few of the highlights. But this report will be available on the FVRA website also for anyone to look at. Exterior walls of the original 1970 building consist of load-bearing masonry walls load-bearing masonry supporting wood roof trusses. Exterior wall construction for the 73 edition consists of load-bearing masonry with exposed block. There was no indication of foundation settlement. Cracks in the terrazzo were found, but it is believed that the cracks are due to shrinkage. The roof of the original building and the 1973 edition is sloped at a 412 pitch. The east and west elevations consist of 5-foot-high windows over a 3-foot-high low wall. The glass is not laminated. And we've got a survey of the interior, but I think, let's see, we'll go on to a later section which really picks up most of that same information as far as recommendations. Code analysis. Today, the Florida Building Code, 6th edition, 2017, sets forth requirements for wind loads used to design buildings. The building is a risk category 3 building, and it is located in a 154 mile per hour zone within Largo, Florida. Risk category 3 would be typical for a building used as an assembly building. The Florida Building Code adopted wind speeds based on ultimate conditions. The 154 mile per hour wind speed, assuming risk category 3, is the ultimate wind speed and is equivalent to a service load wind speed of 119 miles an hour. Okay, an analysis of building components for loads. And there's a table which lists the various conditions and the design criteria. As one can see from the table above, the pressures used in the design for wind in 1968 are significantly less than the pressure specified today. Since the glass is not laminated, it could easily break during a hurricane if struck by flying debris, causing an interior pressure to occur. The interior pressure increases the overall pressure on the building, causing a pressure increase of 56%. Original 1970 building. The roof structure consists of pre-engineered roof trusses spaced at 24 inches on center, supported by load-bearing walls and a steel frame. The existing trusses meet the current building code for wind or gravity loads, except that the connection of the trusses to the supporting members does not meet the current code and should be supplemented. New hurricane anchors should be installed connecting the trusses to their supports, meeting the wind pressure cited in the tables above. 1973 building addition. The roof structure consists of pre-engineered roof trusses spaced at 24 inches on center, supported by load-bearing walls and a steel frame. The existing trusses do not meet the current building code for wind and gravity loads. The connection of the trusses to the supporting members does not meet the current code and should be supplemented. New hurricane anchors should be installed connecting the trusses to their supports, meeting the wind pressure cited in the table above. The 2x6 plate on top of the steel beam should have supplemental fasteners to meet Florida Building Code. The bottom chord of the existing roof truss is overstressed. The top of the masonry cheek wall cannot resist wind loads in accordance with Florida Building Code. Supplement the wall by adding reinforcing to the wall, to the wall, and adding a new horizontal tube. Supplement the full height masonry walls by adding reinforcing. 1981 building addition. The roof structure consists of wood joists 12 inches deep, spaced at 24 inches on center, and supported by load-bearing walls and a steel frame. The existing joists meet the current building code for wind and gravity loads, except that connection of the joists to the supporting members does not meet the current code because they were installed incorrectly and should be supplemented. The joists are supported by two 2x10s and should be supplemented by adding a steel plate to each 2x10. New hurricane anchors should be installed connecting the joists to their supports, meeting the wind's pressures cited in the table above. The 2x6 plate on top of the steel beam should have supplemental fasteners to meet Florida Building Code. 1996 building addition. The roof structure consists of 18-inch deep pre-engineered wood trusses spaced at 24 inches on center supported by load-bearing walls. The existing trusses meet the current building code for wind and gravity loads, except that the connection of the trusses to the supporting members does not meet the current code and should be supplemented. New hurricane anchors should be installed connecting the trusses to their supports, meeting the wind pressure cited in the table above. Conclusion. It is the opinion of this report that the subject building is in fair condition. The building structure did not show any indication of settlement or overstress except as loaded above. Roof framing does not meet the Florida Building Code because the hurricane straps are not adequate. Recommendations. The building structure can be upgraded to meet the Florida Building Code. The following program should be implemented. The original 1970 building, and for you, the original building is the section out in front, behind from here, the second row of columns. Supplement connection of roof trusses to the supporting anchor. Supplement the roof connection of roof plates to substructure. The 1993 building addition, which is essentially where we're at now, coming out, 73. Supplement the bottom chord of the roof trusses by scabbing on a new member. Supplement connection of roof trusses to supporting members. Add a horizontal tube at the windowsill spanning between pipe columns. Add vertical reinforcing to the masonry cheek wall. Add reinforcing to the full height masonry walls. Replace existing windows with laminated glass that meets the building code. Add bracing to the north and south gable end walls. Add fasteners to the wood plate on top of the steel beams. 1981 building addition, and that's the one we referred to from the column out and wraps around to the conference room behind us, and the billiards room and card room were also added at that time. Add new connections between the joists and the support members. Add fasteners to the wood plate on top of the steel beams. Add steel plates to existing 2x10s. Add a horizontal tube at the windowsill spanning between pipe columns. Add vertical reinforcing to the masonry cheek wall. Replace existing windows with laminated glass that meets the building code. 1996 building addition, which essentially is the exercise fitness room. Supplement connection of roof trusses to the supporting structure. An engineer's cost estimate is attached to this report. Total repair renovation costs are estimated to be $719,153. It may therefore be necessary to upgrade the building for ADA. And he has a closure thanking us. And just as a matter of looking